The following is a quantitative research talk that I gave to the University of California, San Diego's Triton Quantitative Trading Group. I discuss my paper, which uses emojis to produce return predictability in the cross section. I outline what it means to have a career in quantitative research, how to position yourself for such a career. I dive into the quantitative research pipeline, all the way from data acquisition to data analysis, and I wrap up with a wonderful Q&A. Over 70 attended the event, which spilled over into 2 classrooms. It was awesome to see so much participation. It was amazing to work with such a great organization, and I look forward to doing more seminars like this in the future. Moreover, these videos and talks certainly take a lot of effort to create. I do not charge universities or organizations for these seminars, so if you'd like to help support the channel so I can continue to create videos just like this one and host more free open source quantitative research seminars, please like, comment, subscribe, share. It helps me out tremendously. It is greatly appreciated. And if you'd like to master your quantitative skills, check out quantguild.com. Maybe you come from a background in business, economics, computer science, physics, and aren't too sure where to get started on your quant journey. Maybe you're an aspiring quant and you're wondering where to focus your study efforts. Maybe you're a working professional looking to switch industries or sharpen those quantitative skills for a technical interview. In any case, Quant Guild is for you. We have over 90 quant lessons in math, probability, finance, an adaptive practice engine that scales with your skill level so you can progress to more and more difficult topics with gamified rank-based progress. Interview questions with fully worked solutions, trading games coming soon, courses from A to Z in math, probability, statistics, finance, data science, coding, all from the ground up. And all that's included with Quant Guild membership. And you can get started right now for free. So if you'd like to help support the channel and master your quantitative skills, check out quantguild.com. Without further ado, I present to you and UCSD's Triton Quantitative Trading, modeling stock returns with emojis. Let's kind of begin by talking about navigating the quant space here. And it's certainly intimidating when you first get started because there's so much to learn. It's such an interdisciplinary subject, right? It combines essentially, right? It combines math, probability and statistics, computer science, finance, and you could argue it starts to combine other fields and some fields, subfields as well, like linguistics, artificial intelligence, reinforcement learning, all those kind of very niche topics in all of these subjects. It kind of feels like it gets out of control very quickly. So, really what I like to say when you start to consider the quant space, whether or not you're considering a career as a quant, the first thing you should do is assess your compatibility for the role. And this is not a trivial task. And very it's very difficult to tease out if this is something that you'd actually like to do professionally. I love math. I absolutely love every part of working on a difficult problem, trying to figure out if there's some sort of analytical, numerical solution, whatever it may be. I absolutely love every component of it. I also really like to build software. So I make for a fantastic researcher in the context of empirical research. I can build, I can prototype, I can come up with solutions very, very quickly. And even though this is the case, I've always had a preference for theory, but I never was particularly suited to the theoretical work. I was always suited to the empirical work. And that's a very important distinction there, being able to identify if you're compatible for this space. Is this something that you actually want to go out and pursue full time? This is the type of role that you want, spending a majority of your day on these difficult problems. And then once you assess, what, this is the sandbox that I want to play in, it comes time to position yourself. To position yourself based on a combination of your interests and natural skill set. So when it came to my interests and natural skill set, right? I had said I'm an empiricist, but I have a preference for theory. So I took a two-pronged approach to positioning myself as a quant. I had this hand in quant research and trading. This consists of a ton of empirical work, very practical. This is, not a place where we're just going to, sit in the lab and come up with like some crazy strategy. No, this is really about coming up with something that you can execute on, right? This is really empirical work that we are dealing with. Now, there's of course going to be a component of theory to it to ensure that you can kind of cross between the lab and practice, so to speak, going from more of an academic space to a practitioner space. So there is some theory there, but not as much as I had a preference for. So I always took this focus on equities and equity derivatives in the context of quant research, quant trading. Now, that was the empirical prong, but what about the theoretical prong? My personal preference, right? Derivatives pricing. There is a ton of theory involved, and that is what I had a preference for. Studying stochastic processes, studying pricing theory, specifically equity options, extrapolating exotic prices. This is where all of my interest pretty much still lies. In terms of this two-pronged approach, I still have a very strong preference towards this theoretical work. It's what I prefer to wrestle with all day. And the nice thing about this theoretical work is there's even space for machine learning and artificial intelligence in current streams of literature. So I really like taking this two-pronged approach because it enables me to pursue opportunities that I'm particularly suited for. And it gives me a little more versatility in my approach when it comes to things like the job market or different projects that I'll operate on in a contract capacity. That was my approach. Now, in terms of the roles that I was looking at, I was looking specifically in QR and QT, right? These are quant research, quant trading roles. And I never really was particularly suited to quant dev. That kind of just took the computer science a little too far than I was interested in. I never really had an interest in developing low latency systems. I have experience with C, C++, Java, so I'm aware of how these systems operate, how they're built, the different design patterns, so on and so forth. But that's not what I wanted to spend all of my time on. And that's a really important distinction, is figuring out what it is you're going to be spending your whole day on. You want to be enjoying the work, right? And that's something that I wish that I focused on more earlier as a student, because I think I would have kind of ping-ponged around less and I would have focused more on this two-pronged approach. So I would certainly encourage you as a student, if you're looking to get involved in this space, you're already a part of the quant trading club here. That's a fantastic start. Continue to assess your compatibility for different roles in the space, and then look to start to position yourself for these different roles. Maybe you start writing, maybe you start a blog and you start talking about quant research. Maybe you start talking about pricing theory. Who knows? That'll depend on your interests. But that is my advice when it comes to getting started navigating the quant space. And this is certainly a rabbit hole. We could dive down and talk about this for hours at end, how to go about structuring this optimally, but I will digress for now. But I think this is a great place to begin the talk, because this kind of shows you where we're working in. This shows you context for the research project that I built in an academic capacity. So this talk specifically is focusing on a project in this space, in the quant research trading space, but from an academic perspective. So research in an academic and industrial setting are somewhat equivalent, but their outcomes certainly vary. Roughly, you can think of this as pursuing some sort of open source publication versus some sort of for-profit implementation. And this will largely depend on your firm and the types of problems that you're working on. So let's talk about this difference between academic and industrial research. We're focusing on this idea of quant research, quant trading, and we're going to talk about my academic paper here. How many words is a picture worth? Using emojis from social media to predict future stock returns. Now, I very much dislike the word predict because I think it sends the wrong signal to especially students who are first getting involved in this space that these returns are in fact predictable. I want to, and if it's beating a dead horse, fantastic. That means the point was delivered. I want to overemphasize that there is no prediction in this space. There's no such thing as predicting a future return. There's no such thing as predicting a price path. Effectively, everything is uncertain, and we typically model it in terms of randomness to model that uncertainty. And when you're making trading decisions, whether it's in this context in a quantitative trading capacity or as a discretionary trader, you can frame this as a market maker. The list goes on. You're assigning likelihoods to different outcomes, and you're executing trades based on those likelihoods. And that's how you continue to accumulate wealth, right? We're not going to take our entire portfolio and bet it on black. And then, oh, if we hit, great. And if we don't, we're out of money. And now we need to raise more capital, right? It doesn't work like that. So I don't like the word predict for that reason. I want you to think in terms of prediction here. Think about explainability. It's able to produce some facet of explainability in the cross section. It is essentially coming up with a very valid way to assess the likelihood of different moves in a forward-looking sense. And that's really what I want to emphasize here in the context of prediction. All right. So what's the difference between academic and industrial, private, whatever research, right? Well, academic research, I'll focus on a few components. All right. First, if you're trying to answer a research question, it is difficult to get data. And what I mean by difficult is, and we'll see later on in the context of this paper, the question that you're trying to answer may or may not have valid data sources available. In this sense, right, with this particular paper, what would I need to answer this research question? Well, I'm going to need data from social media. How do I go about getting it? Institutions certainly have data sources, but I'm going to have to pay for those data sources. They're not available for free. Now, sometimes institutions will actually have academic access, and you'll be able to build those engines to manage those data pipelines yourself. We'll talk about this in a moment, but even still, if you have to build that entire pipeline yourself, that is certainly going to be a large project. It's a big effort. So difficult to get data. All right. That's what I want to emphasize here. You could spend months building an engine to query all this data to try to answer a question, and then you don't get any result. Now you got to pivot. Maybe there is no result there at all. And now you're scrapping the whole project. And this happens a lot in the space. In the context of academic research, a PhD is typically necessary for tenured positions. If you want to pursue a career in academia, you certainly need a PhD. And that is a dedication in itself. You have to know that that's where you want to be. All right. And of course, all of your contributions are typically open source. Now, there is some industrial collaboration. You can consult privately. And yeah, you have a lot of flexibility as an academic once you get there. But the pursuit of that goal, academic research, that has to be your trajectory. Okay. There, of course, is a publisher perish culture in some sense. But again, I'll digress from this so we can talk about industrial research. Now, in the industrial research sense, private research, it is easier to get data. And when I say easier, what I mean is if you're at a big institution, maybe they're a fintech company, a data provider, maybe they're some sort of bank or hedge fund, very likely they will have a lot of data. They will have access to a lot of data, and you as a researcher will be able to ask and answer interesting questions with the call of an internal API. That is awesome. That is awesome. You don't have to spend
an incredible amount of time building that data processing engine, that data querying engine, and you can just continue to iterate, continue to ask more research questions. So in that sense, yeah, research is going to be faster in industry, right? Moreover, a PhD is not necessary for these roles. All right. When I got my first QR role, it was without a master's degree. Okay. Moreover, in this context, it's not usually open source, your contributions, right? Mostly they're going to be internal. Sometimes there's collaboration with academics, sure, right? You see that at tech companies. Maybe you see that in some sort of like pure research capacity. You're trying to make an algorithm more efficient, things like that. But in terms of trading and research, yeah, it's going to be proprietary, right? I have a remark slash opinion at the bottom of this slide, and I try to separate as best I can the difference between fact and opinion for everyone that listens to any of my content. And my remark slash opinion is, do not get a PhD because you want to go into quant research and it's going to be, arbitrarily easier to do that. You should get a PhD for the same reason that you should get a graduate degree, because you really, really love what you're going to learn and you want to study it in that capacity. That is my best piece of subjective advice for you. Pursue a PhD or a graduate degree because you have a passion for this subject. Okay. Passion does not equal want to make lots of money, right? Those two things are not equal. Otherwise, I promise those 5 years, 5+ years will be quite difficult. All right. So fair enough. Knowing this is the difference between academic and industrial research, right? We're going to focus on this academic research component. That is the capacity this project was created in. So there's really no notion in an academic sense of qualitative research when it comes to finance. Even if you don't get a PhD in math, computer science, statistics, some sort of quantitative, purely quantitative field, you're going to be operating in a quant capacity anyway if you get it in some sort of like more qualitative, and I use that very loosely, qualitative field like finance or economics. You are going to be running regressions. You are going to be trying to tease out causality. I promise there is no such thing as a PhD program in finance where you don't touch Python, SAS, any form of linear regression, fuzzy regressions with different discontinuities to try to tease out causality, so on and so forth. Every single type of PhD in the academic space at this point is going to involve some quant work. All right. And here I say, yeah, I suppose there certainly are varying degrees of quant, but again, I'll digress. All right, this brings us to the academic research questions for this particular project. Academic research questions about emojis. So when I was working in industry, I found I was working specifically with social feeds, news, social text. And one of the things that I observed, and I'm sure many of you may have observed as well, is the meaning of words and words in the linguistic sense, computational linguistics. If you're studying language processing, they're called tokens. So these tokens tend to change meaning over time. I have an example here, to the moon, rocket ship, a moon emoji. And we know now, right, in terms of like, a crypto finance bro, whatever, we're just saying, all right, let's watch this stock go up, or we're calling for it to go up. And, that's great. But what about 10, 15 years ago? What did to the moon mean? Did it mean anything at all in the context of finance? No, likely not, right? So very quickly, we see that the velocity of language it's certainly faster in the context of social media for sure. But even still, right, while this language changes over time, we can ask some very interesting and important questions. So the first one here is, does the meaning of words or tokens change over time? Well, as I gave this example with emojis, yeah, it's not a novel idea, right? Language velocity is well studied. If you talk to a linguist, then they're going to be like, yeah, Old English is very different, at least Shakespearean English, right? You go way back, and I'm not a linguist by any means. I just have a preference for studying language processing, right? But you talk to a linguist, they'll be like, yeah, look, this stuff changes over time very clearly, right? They'll probably largely agree with you that the velocity of language changing over time has increased with things like social media. Different slang comes in and out of use, so on and so forth. So the first question that I had was, does the meaning of these words tokens change over time? All right. A more important idea, right? Is there any way to capture that meaning at a specific point in time? Now, this isn't necessarily novel in the linguistic sense, but it's certainly relevant for a back test, right? Because I just told you 10, 15 years ago, to the moon didn't mean anything, right? We're talking about going to outer space, right? This is no finance context at all. So, is there a way to capture this meaning at a specific point in time? More importantly, can we capture it as it changes through time? This idea of sort of a mean process changing over time is paramount to quantitative finance. Every model that you build is going to suffer from the reality of non-stationarity. Every single model. That is a very, very difficult problem to deal with in practice. You can try to model this non-stationarity with exogenous factors. You can try to incorporate some sort of regime changing model, some sort of mean process that changes over time. But even with those models, it's not a trivial problem. It's a very, very difficult problem to deal with in practice. Okay, so if there is a way of capturing this meaning at a specific point in time, can we apply this methodology to emojis? I don't see why not, right? If emojis are just another token, another word, then why can't we apply this point in time, this point in time measure of meaning for a word to the emoji tokens themselves? Now, several models do this, but none in a time varying capacity. So, out of the box, if we just look at different models to model language, yeah, they handle emojis, and this is well documented. There's plenty out of the box that do this, but again, this time varying component, that's what we're interested in. Now, this is probably the most important question. Do emojis offer unique information? Unique information, incremental information in cross-sectional return prediction. You all know how I feel about the word prediction, but I'm going to use it here. All right. Now we're really getting somewhere in terms of a novel research question. So hopefully this is making sense. The series of questions that kind of built to this big ask, right? Everything may be well defined, well studied, but you start to put all of these pieces together, you start to approach the frontier of knowledge, and maybe you're making a very tiny dent in what is well documented, what is well known. And then that's from more of an academic perspective. Then you can see if you can profit from it in the industrial setting. All right. So now we're asking this question: do emojis offer unique information in cross-sectional return prediction? How do we answer these questions? What does quant research look like? Everyone wants to be a quant researcher. Everyone wants to be a quant trader. You're a scientist. You are answering questions. That is effectively what you're doing. You're trying to expand knowledge. All right. Here is a process map of this academic research process. I could walk through an entire, slide deck of the scientific method, applying it, appropriately, so on and so forth. But here we're just going to focus on three critical stages: data acquisition, data science, and then data analysis. All right. This is really where you can start to see if you're suited for a role in research, because I've always been very suited to empirical work. I can prototype quickly, I can implement APIs quickly, and believe it or not, I wrote all this code without AI. This was before ChatGPT. I didn't have Copilot. I didn't have Gemini. I didn't have Cursor. This was a heinous landscape before these AI development tools were around. I mean, this was all written from Stack Overflow. This was hard work. So the times have certainly changed, and your ability to produce new research and the speed in which you can iterate has certainly changed. But effectively, I want to outline these 3 stages of the research process. So as I said, I was suited for this work. I'm a very strong empiricist. So this is where I spend most of my time. Data acquisition. How do we get data? Academic access, institutional access, query it yourself. That would be a project. All right. After data acquisition, data science. How do we model the data? Cleaning and pre-processing, sentiment modeling, feature engineering. I find a lot of times when students take, and really I think it's a shame, when students take linear algebra, differential equations, they don't immediately see how crucial those skills are when it comes to even a process pipeline like this to produce effective research in this stage of sentiment modeling, feature engineering. You have to be capable in the sense of computing a principal component analysis. What are you doing, right? How does that actually function? What do I do? I'm not just throwing different tools from my toolbox at these different problems. I need to understand theoretically what's going on. What does the spectral decomposition look like? Is there a gradual decay? Is there a rapid decay? These things matter because they impact the results downstream. If you don't understand theoretically what's going on, then how on earth is your analysis step going to be sound? If upstream, you were just like, yeah, I think I threw PCA at the problem, then I threw ICA at the problem, and then I was like, oh, really, I should normalize it. So I threw a normalizer at it. Like we can't operate like that, right? We need to understand the theoretical basis for our decision making, what assumptions go in to each step along the way, and how those assumptions could be violated in practice, and how that impacts our overall analysis step. It's critical to producing valid research, right? In an academic sense, yeah, you could key mine your way to a publication. Maybe it's extremely difficult to corroborate. You have a proprietary data set, fantastic, but you can't profit off of that, right? You can't trade with that information. It's food for thought, things to think about. So once you move past this data science step, you acknowledge, okay, a lot goes into it. You need to be a very high level programmer, a very high level mathematician, statistician to understand the implementation of all of these tools in your toolbox, how they work together. Now you can effectively put together a data set for analysis. This is where you do regressions, you do back tests, you look at things like stability in a forward-looking sense. All right. 95% of the time is spent on data acquisition and data science. You must enjoy this part of the work. All right. The fun part is the data analysis part. Everyone wants to do the back test. I want to do the back test. I don't want to do the data acquisition work. I don't want to do the data science work, right? Now, I've always fortunately enjoyed that component of it. As an empiricist, I really appreciated the math, theoretically, how it was applied in practice. I didn't mind spending 95% of the time on the data acquisition, on the data science. But if you do, then really you need to start to pivot. Think about different roles in the space. If you don't want to operate in this capacity, maybe you're more suited to be a risk taker, more in the trading space itself. Maybe you're more suited to be a developer, focusing on low latency programming, so on and so forth, right? Now, I will say, depending on the firm that you work at, it will dictate whether or not you get to iterate very quickly on research ideas, or if you have to spend time on the data acquisition and data science step. That's a very important distinction, right? Because some firms, you're going to have to do that all yourself. You'll acquire the data from some sort of internal, data API call. Maybe it exists in some sort of lake, whatever. And then you do all the data science yourself, and then you produce the results yourself. you wear a lot of hats in that sense. Sometimes there are teams of, PhDs, some of the smartest dudes and smartest ladies in the world who are maintaining those components of the pipeline. They're working on this data science, they're working on this data acquisition, and then they're supporting that as an internal product. And then researchers go about producing data analysis so they can continue to iterate very quickly. And that makes sense, right? Because everybody is essentially optimally performing in a parallel capacity, right? So it depends on the firm you work at, it depends on the size of the firm you work at, and so on and so forth there. All right, so this is the process map for academic research. Let's walk through this research process where we actually deliver a result in the context of my academic paper. So this process is to answer these questions. Does the meaning of words change over time? Is there a way to capture the meaning at a specific point in time? Can we apply this methodology to emojis? And do emojis offer unique information in cross-sectional return prediction? Step one, data acquisition. All right. We need to figure out what data we need to answer this question. This is not something that anybody is just going to sit there and tell you, right? You have to figure this out. This is research, right? You collaborate with others. Maybe you should use, this type of data. Maybe you need this. Maybe you need this. Here's what other people have done before. This is where a literature review comes in handy. What has been done? Don't reinvent the wheel. That stuff is all open source. Hop on Google Scholar. If you have a question, go on Google Scholar, type it in, see what papers may go about answering it. It's not going to answer it directly, right? If you're like, okay, maybe CEO facial expressions have some sort of return predictability, right? You're not just going to go on Google Scholar and see a paper, oh, CEO facial, no, it doesn't work quite like that, right? You actually have to conduct the literature review yourself, see what has been done in that space so you can continue to extend results. You don't necessarily have to reinvent the wheel, right? So that's going to help you in determining what data you actually need to answer these questions. Data required, all right? So what did we acquire for this particular project? Well, we need an equity universe. We can't just pick whatever stocks we want. That doesn't make any sense. Well, I'm going to pick NVIDIA because I like NVIDIA. I'll pick Apple. I'll pick Amazon. No, I need an equity universe. All right. So am I using the S&P 500? Am I using the Russell 3000? What am I going to choose? What am I going to choose these stocks from to analyze return predictability in the cross section? Okay. I need pricing data. I need high quality pricing data. Where do I get this from? I can't just go on Yahoo Finance and get returns from Yahoo Finance. Again, the quality of the data here is going to dictate whether or not downstream my results are even reasonably valid, right? I'm trying to control for a lot of measurement error along the way, right? I can't just induce error wherever I like or, take kind of a shortcut. I need to ensure that every step of the way, I'm producing a high quality result. So pricing data, I need high quality pricing data. And probably the elephant in the room, social data. Where do I get this? Where do I get this social text data from? Tweets. Where do I get this from? All right. How I access this data will depend on the scope of your project. As I said, academic or institutional work. So fortunately, from an academic perspective, the equity universe and the pricing data, get out of town. That was easy. My co-author had the Russell 3000 equity universe that's rebalanced every year in July. This is changing going forward. That's a big deal. It was rebalanced once a year, and then going forward, it's going to be twice a year. I'm not sure when the new change is going to be made, but this is how it used to function. So it was every year. So I had a list every year to ensure that I didn't bias my data, right? I didn't bias how I was going to be producing the analysis downstream. So, okay, I have my equity universe. It's going to change over time, and I'm accounting for that. Very important. Pricing data can hop on words. You guys familiar with words? Maybe you've heard it before. It's an academic database. You can access a lot of data in an academic capacity here. That's where we got the pricing data from. All right. The scope was academic, very easy to access. What about the social text data, right? Now, if I was operating in an institutional capacity, then I wouldn't have access to words necessarily, but my institution would certainly have the Russell 3000. It would certainly have the pricing data. Now, of course, we're operating in an academic way here. So we're trying to figure out how we go about getting this social text data, right? We crossed off equity universe, we crossed off pricing data. Where do I get this social text data from? In an institutional capacity, that is way too expensive. That is way too expensive. All right. This is not something where you're going to drop tens of thousands of dollars on access to data to try to answer a question that may or may not have some sort of solution that is publishable, right? That's not how we can operate in an academic capacity in an efficient way. So there's no academic access for this data in the context of it being prepackaged institutionally, right? That's a very big distinction here. It wasn't prepackaged institutionally, all right? Institutions did have it in a prepackaged sense, but too expensive. Doesn't leave us many options, you know? And this is really where it comes into play here. You got to kind of strap yourself up by the boots there and go to work and do it yourself. So this is effectively where, at this point of the process, I realized very quickly I had to build the query engine, and we were going to go about constructing this entire data pipeline from scratch. Okay. What does that actually look like? Right? I mean, I say these things, a data pipeline. Oh, you know, we got data from a data pipeline, but I want to tell you how it works. How did I actually get this data, right? Data acquisition. What do we do? I'm not just going to an institution or some sort of academic, you know, university, whatever, that has this data already. I need to go get it. I need to construct the data set myself. All right, how do I do this? Well, first, we need our equity universe. This is easily accessible, right? I had access to this. It rolls over time. Then I need to query data. I need to query data from somewhere. Where do I query data from? Well, Twitter, this is before X, Twitter had an academic API. It was capped. You could only query a certain quantity of tweets in an academic way. And what you would do essentially is construct this iterative API call to Twitter to send you tweets based on some sort of criteria. And the criteria that we used was every single tweet containing a cash tag. And you can see here I have cash tag Apple as an example. That's 0.2 here. I'm looking for tweets from Twitter that contain a cash tag. How do I determine the cash tags? That's going to be based on my equity universe. Okay. So my equity universe at that specific point in time tells me, you know, 3,000 tickers that I need to query tweets for. All right. I need to account for the rebalancing. So I'm going to query tweets up until that equity universe is good until then I truncate and I have a new equity universe. And I do this in a rolling capacity. Now, one thing that you will very quickly notice, and this is where things start to blow up and things start to get very difficult, is how many tweets do you think there were? Right? There were a lot of tweets. I'm storing all of that data. Okay, this took quite some time to query, not just because we were capped in terms of how many tweets we could pull in an API call, but it's a lot of data, right? Over 87 million tweets. 87 million, that's a lot of data. That's a lot of data for a prop data set. And it's just sitting right here on my desk on an SSD right now. but it's a lot of data, right? You're going to pull that into some sort of data warehouse. It'll exist hopefully in a lot of different places. You'll have some sort of AWS bucket. You'll have some sort of hard copy as well. And that is effectively how you go about constructing some sort of data pipeline, data acquisition pipeline. All right. Since Twitter was purchased by X, Elon Musk purchased Twitter, right? The API access is no longer available for academics. It is now a paid access point. So this entire, dynamic of being able to just query tweets in an academic capacity isn't really there anymore. So this is still novel in that sense. If somebody had institutional funding to go out and fetch those tweets, then yeah, they could continue to roll the ball forward on this research and look to trade in a live capacity with it. But we'll talk about that more towards the end of the talk here. So in the context of data acquisition, this is precisely how it works. When you have to do it yourself because an institution, either academically or privately, doesn't have access to the pool of data that you need to answer the question, you got to build that yourself. Now, I want to emphasize the best questions don't have prepackaged data solutions available to you to answer them. Essentially, what I'm saying is there's this sort of inverse relationship between data accessibility and the rank of how interesting the question is that you're interested in answering, right? The harder it is to get data, the more interesting questions you can answer. And that's really where you can make the biggest dent, all right? It's always easier to speak in terms of a data base than it is to just tell you what it looks like. I don't understand really why more presentations don't include just a simple table. We always operate in what? Data frames in R, Python, whatever we're using, right? So we should kind of just get a gist of what it looks like. My data acquisition pipeline that I just showed you produces these tables, these data frames. I have the firm. Where did I get the firm from? Well, when I run the query, I got to pick the ticker, right? The ticker was dictated by an equity universe, and that rolls throughout time. So every single document that Twitter returned to me in an API call, I'll have a firm attached to it. This is what it looks like. Firm document, to the moon Apple, bearish on Apple, to the moon Amazon. You get the picture here. There's also a timestamp for all of the tweets. This is particularly important. If you're trying to do any return predictability, you need to what? Consider a cutoff for actionable time, right? Before 9:20 a.m. on a trading day. Of course, this is going to roll throughout time as well. So 2017 to 2018, 2018 to 2019, you can see the equity tickers that are involved in this data set are going to roll as the Russell 3000 rolls, right? It's going from July to July, right? So you'll see the constituents change over time as well. Now, we're ready to move on to the data science step in the process. This is the data acquisition step. Now we got to talk about the data science step. This is where things kind of just begin to get, I'll just say it gets bananas, absolutely bananas. There are probably an infinite number of questions that you can ask at this stage. How do I manage stop words? Foreign languages? An imbalance in data across firms? You think that Apple is going to have as many tweets as AMD? Outliers in any capacity. What do we do? How do we extract signal from the text? Signal, tradable signal that produces return predictability in a cross section. How do we handle multiple measures of sentiment? There's not just one way to determine if something is positive or negative. There's emotion, right? Happy, angry, sad. Which one should we pick if we're trying to predict returns in a cross section? How do we handle documents, these tweets, with multiple firms? How do we do that? If there's a tweet and it says what? To the moon, hashtag Apple, but I hate Amazon. How do we handle that? Do we treat that as one document? That's noise, right? This is before LLMs. We didn't have the ability, and of course, it's still computationally inefficient, but we couldn't just ask an LLM to interpret the document. And even if we did that, there's going to be some error there because there's a non-zero probability of failure. So hopefully, I'm not just going to continue to read these off to you. Hopefully, you're starting to see where the research experience comes into play here, right? You need to understand all of the tools that you have in your toolbox. You need to understand what it is you're looking at in terms of a data set and the things you can do to aid in answering all of these questions. This is acquired through experience. You talk with senior researchers, you talk with senior data scientists, you figure out maybe I need to bring in other data. Maybe that will help alleviate some of these concerns about signal to noise. Who knows, right? We could spend, and I would love to, trust me, we could spend all day talking about all of these, questions, the different methodology, different approaches. But I want to focus on the primary contribution of this research, right? These point in time sentiment modeling techniques, right? That's what we were talking about as a research question toward the start of this presentation here, right? That is effectively where we're trying to go. We're trying to build this ability to measure sentiment of emojis at a specific point in time. So let's focus on that question. All of these other questions, extremely valid, right? They need to be handled. They can be handled in so many different ways, right? This is that experience component. This comes into understanding the quantitative techniques in your toolbox and being able to apply them. What is this idea of variation explained? If I have 20 sentiment measures, but 2 of them explain the most variation, then how many do I need? What kind of linear combination of all those sentiment measures can I produce to effectively compress all that information into 1 or 2 that are linearly independent? Linear algebra. You need those quantitative techniques to answer these questions. Otherwise, you're just going to be shooting in the dark. All right. Let's talk about this idea of point in time sentiment. It's a very cool idea, and it's actually really intuitive. So here, words in a social context, tokens. We can talk about words, we can talk about emojis, whatever we like. The sentiment, how positive it is, how negative it is, its meaning changes over time. There are many approaches to modeling sentiment. Dictionaries, machine learning techniques, now we have LLMs. But how do we assign meaningful scores to this text at a specific point in time without introducing our own bias, right? Now I know To the Moon has this positive score, but is there a way to do that in an unsupervised way? I want the text essentially to speak for itself. So how should I model these emojis? You look at stock chart up, stock chart down, green, red, rocket ship, happy, angry. And yeah, you want to rank these scores, right? Here's a tweet for you. Hashtag Apple, stock chart up. We want to effectively throw it into a model and have it produce a sentiment score. And you can see that score is positive, right? And you all would probably agree with me that that should be a positive score for the tweet. We need to build this model. We need to effectively build this model to produce and extract the score for analysis and regressions, backtests, so on and so forth. All right. How do we do this? We want the scores to be intuitive. They should make sense. We have a problem if stock chart down is positive. We have a problem if rocket ship is negative. We need to be able to have an intuitive representation of these emojis in terms of a score, but also account for variation over time. This is where the idea of a point in time sentiment measure comes in. Effectively, what we're doing is we're applying a general sentiment model. This is something that we would consider to be relatively stable over time, time invariant. Amazing. Did the meaning of amazing Not in a sarcastic sense. Did the raw meaning of amazing change all that much from 2000 to 2025? Probably not, right? What about great, good? Yeah, probably not. What about bad, awful, terrible? Probably not. So what we're going to do is we're going to start by applying a general sentiment model to all of these documents. So you see each of these documents, right? I'm going to apply a general sentiment model. Each document is then going to get a score. All right, then how do I produce a score for the emojis? I'm going to take an average of the sentiment across all of the documents, and then I'm going to use that as the score for the emoji. Now, by the central limit theorem, this would be normal at the point in time. That is an incredibly useful result. That is incredibly useful because now I can answer questions about that score. I can answer hypothesis tests about if it's indifferent from 0, right? Is it greater than 0? Is it less than 0? I can apply those hypothesis tests because I don't care if the meaning changes over time. I need to know now. I want to know at this point in time. So even though there's this time varying nature to the censure of the normal distribution by the central limit theorem, it doesn't matter because at this point in time, I want to know, is this positive or is this negative? That is key here. And it is a very elegant idea. Effectively, what we're doing is we are developing measures for the emojis, the sentiment of those emojis, in an unsupervised way. I'm letting the data speak for itself. And this is also going to account change in the meaning over time. So, what were the results? Well, let's look at how this actually is constructed. If we look at lots of tweets in 2000 with the rocket ship emoji, we can see billionaires going to the moon, right? That's going to produce what? 0 for positive, 0 for negative. That doesn't really have any sentiment attached to it, right? We're going to look at a ton of tweets in 2000 with the rocket ship emoji. We'll take a look at the overall sentiment, positive and negative. We'll take the average, and that's what we're going to assign to the rocket ship emoji. So you could see in 2000, right? The meaning of the rocket ship emoji is going to be based on what was observed in 2000. And the same is going to be true for 2018. We're going to apply that general sentiment model. We will take the overall average of the aggregate sentiment and apply that to the rocket ship emoji. So this is the methodology, but does it actually work? This was the really cool result of this model structurally. This is what we find in the data after applying this methodology specifically to emojis. We find what? Stock chart up is positive. Stock chart down is negative. Green is positive. Red is negative. Rocket ship moon positive. Happy face positive. Angry swearing face negative. I didn't assign those scores to those emojis. The data literally spoke for itself and told me those values for each of those emojis. That is cool. That is effectively social text speaking for itself at a specific point in time. Now that we have a model capable of assigning text, specifically emojis, this point in time score, we can do this for all of the documents in our database. So you see this table now, right? Firm, document, score. We can apply the model to each of these documents and get a score. They make sense economically, intuitively, and we didn't impose any structure, whether or not they were positive or negative explicitly. That is so cool. That is so cool. The data literally spoke for itself, and it told us that all of these were positive and negative respectively, and it makes sense intuitively. If you were to just look at these emojis, that's awesome. Okay. So is it useful? That was a lot of effort. That took a lot, right? We go through the data querying process, we go through the data science process. That was a fraction of the data science process, right? That was an outline of a key contribution of the paper in terms of methodology. Like, that didn't get into any other components of the data science itself, right? So 95% of the work at this point is already done upstream. The data acquisition, the data science steps, that took months. Months of my computer just sitting there running these pre-processing engines, these acquisition engines, and it took just an incredible amount of time because I effectively what? I queried this data from scratch, and then I ran these pre-processing steps and this data science step and this new methodology for point in time sentiment, all from scratch. There was nobody to maintain a data set. I didn't just query it from an institution, right? I didn't query it from a private institution, a public institution, whatever. Had to build it myself. So 95% of the time was spent there. Now we get to the fun part. Is it useful? We answered all those other questions. We answered those questions upstream: data acquisition, data science. Now we get to the data analysis step. This is the fun part. This is the part where we get to go, awesome. Let's take a look and see if this is actually useful. Do emojis offer unique information in cross-sectional return prediction? In the finance literature, there's a lot of study of text and the impact in future stock returns in a variety of different contexts. We have Lager McDonald, we have Tetlock, we have a lot of different studies that look at a combination of news, corporate 10Ks, we have even social text, Antweiler and Frank. So this has been studied before, but what about in the context of emojis? If we are trying to figure out if this measure is useful, we need to consider established sentiment measures in the literature, word-based sentiment measures. So that is effectively what we do. We're going to conduct a regression analysis, and we are going to account for things that have known explainability and variation of future returns. We're going to look at established sentiment measures. We're going to look at past returns. We're going to look at firm size, book to market ratio, time fixed effects, news sentiment, corporate disclosures. We're going to use heteroscedastic robust standard errors. We need to consider this autocorrelation structure. What do we observe? What is our big result here? We observe emojis, after accounting for all of these effects, still offer statistically significant return predictability. Here, we observe the cumulative abnormal returns as our dependent variable in the cross-section and find an economically meaningful result in the incremental information offered by emojis. All right, this is the main purpose of the paper, the main result of the paper. If there wasn't an economically meaningful interpretation, there would be no use for this practically. And an academic setting, whether or not it can be published is subject for discussion. But a one standard deviation change in our point in time sentiment measure for emoji is associated with an incremental annualized return of more than 5%. Moreover, there's no evidence of this price movement reversing in the coming weeks or months. That's a big component to analysis in this literature, whether or not the result is ephemeral. Moreover, we can start to slice and dice the data in different ways. New gen accounts versus old gen accounts. We look at things like accounts that were created 2020 plus versus accounts that were created before 2020. Turns out most of that alpha is driven by those new gen accounts versus the accounts that were these old gen accounts before 2020. This is really where, you can continue to iterate off of a data set like this. Now that we have this data set, what other interesting questions can we answer in an academic research capacity? What other levers can we pull? What other questions are there that are open-ended in the literature, in the social sentiment literature, so on and so forth? Yeah. Cool. But is it tradable, right? Is it tradable? Long answer, we have a lot of considerations and optimizations to make to determine if this is something that is in fact tradable, right? In an institutional capacity, right? You have you can deal with this overhead. You can deal with this data acquisition overhead. Let's say that I built this data query pipeline. There's no more academic access, but I need to fund it privately in order to trade it in real time, right? That's not something that you're going to face as an issue in an institutional capacity, right? So, in terms of infrastructure for the data pipeline process, institutionally, yeah, I mean, that's not too much of a concern, but privately, right, as some sort of retail quant trader, there's no way. There's absolutely no way you're going to fund that. Just in terms of sheer risk of that alpha decaying, there's no way. Execution speed, who's going to build that system for you? Right? Does the speed matter? What time frame are we looking to trade these over? A day, a week? What kind of portfolio turnover are we looking at? Are we looking at transaction costs that eat away the entire performance of this strategy? How efficient is our pipeline? Can we get all the data that we need before 9:20? If we can't, is it sufficient to run statistics on the data that we have as a proxy for the portfolio that we trade on that given day? All of these things are things that we have to think about when we go about deploying these strategies in practice. If we actually are observing a statistical mispricing, we conduct our regression analysis, we do our back tests, and we see some sort of Sharpe ratio we like, some sort of drawdown we like, and we're interested in its ability to produce similar results in a forward-looking setting. Effectively, we should see stability in those performance metrics. And we should see the performance metrics decay as we allocate more capital to the strategy, right? That's just how scalability works. It's not a trivial problem. It's a very difficult problem. And why your performance metrics decay in practice could be due to a variety of different reasons. You allocated too much capital, it's crowded out, other people are trading it, there's no more statistical mispricing, it converges, right? So it converges, collapses, the decay in performance value. This is a question that all of you, anyone who's interested in quantitative trading, should be extremely eager to ask. If you have a strategy that is working, when do you stop trading it? When is too much degradation in terms of performance? That is a very important question to ask. So, long answer here, it depends. Short answer, I'll say yes. And I've seen strategies like this one deployed in several different capacities at several different firms. All right. So, in terms of the research process, right? We walked through each of these stages: the data acquisition process, the data science process, and the data analysis process. I'm hoping that this elucidates the space for you in the context of what research actually is going to look like if you decide to step into a role in that capacity, right? In reality, there's a lot more that goes into this entire process, right? You're considering at each stage, is there any bias? Are we doing everything correctly? What quantitative tools can we apply to maybe improve our signal to noise ratio? What things upstream? What different levers can we pull? How is that going to impact everything at that point in the process? And of course, downstream, we haven't even spoken about this idea of overfitting, right? You can overfit noise. That's very possible. If you try to select optimal hyperparameters, you very well easily could overfit to a particular result that you found, and then out of sample, it doesn't it's not reproducible, and you don't have this stability in a forward-looking setting, and it's not tradable. And that's a big problem. And that's not an easy problem to solve. So this entire process it's very difficult. And I have a remark for you here that 98 plus percent of the questions that you ask or try to answer may not have very interesting answers at all or actionable answers. They may yield, in fact, unsatisfying or inconclusive or even misleading answers. This is the nature of the industry. You could spend 6 months, a year to several years wrestling on a particular question or project, and it very well may come to essentially nothing. But I want to emphasize that that's not a sunk cost. And I think a lot of times when we hear about this space of academic or industrial research, we're very quick to, just throw out, oh, you wasted all that time on a project and it didn't come to fruition. No, not at all. You were developing as a researcher throughout that entire process. That is not something that you can take lightly. Experience is not gifted to you, it is earned. If you go through 6 months, a year, and you don't get a project that comes to fruition, you accumulated a lot of experience. Again, earned. It is not gifted to you. It is not a sunk cost. You are always developing as a researcher, and that is the goal in this space. If you have any desire to be some form of academic or industrial researcher, keep this in mind as you operate in the space. Remain optimistic. It's not about finding results. That is not the point. We're not trying to data mine interesting results to publish. We're trying to develop as researchers so that we can continue to improve how we iterate, how we operate, and of course, the quality of our research that we produce. So with that, I will say thank you guys. I definitely appreciated the time. It was wonderful to speak with all of you today. I hope you enjoyed. I will leave this open to questions if anybody has any. If you guys have questions about, whether it's this research project, general career questions, whatever it may be, very happy to field those now. But again, Rudy and the exec team there, thank you so much for putting this together. It was a great experience here. Thank you guys.
Just wanted to say, we have a room of over 70 people that filled up. It was overflowing, so a lot of interest. Thank you so much for your industry experience and so the research side. So most people are interested in the academia side and the research. So thank you so much for coming to talk. And any questions, I'll just funnel them over. Does anyone have a question? Yeah, question right now?
I have a question. Yeah, ask him what he did while his computer was running on the computer. From experience, because I sit there and watch it.
Do you have any pastimes while you let the code run?
So it's funny you say that. I had the remote desktop on my phone, so I would check in on it when I was on a run or at the gym and just make sure everything was business as usual there. I tried to keep myself busy with the theoretical research side, trying to continue to conduct literature reviews and work on other projects that didn't demand my computer in that capacity. That's a good question. I've never gotten that one before. That's a good one.
Yeah, thank you. Any more questions? Yep.
What's the specs?
What specs are your computer? A lot of people interested in your computer today.
Oh, dude, I need an upgrade. I'll tell you that much. I just installed a whole bunch of RAM on my computer because I have to edit these videos. So I have about as much RAM as you possibly can have. I think I have 256 or 128 gigabytes of RAM. I have an RTX 4090, and I think everything else is just kind of like whatever this kid who built my computer chose for me. So that's what I'm working with. But I need a new one because this was built in like 2020, I think 22. So it's time for an upgrade, I think.
Yeah. No more questions? Can you hear me? Go for it, or else I'll phone it over.
On your sorry, I'm not really not trying to. So on your research on emojis, like to predict like stock movements, what are your thoughts on like gambling sites using that sentiment to predict something? Because ever since the Supreme Court like reversed the decision, it's resulted in an influx of like sports betting sites. And I'm gonna specify like politics. So sports betting sites predicted like the outcome of an election like hours in advance, and as well like if tariffs were going to be placed or not. So I was wondering, what are your thoughts on using like that data from gambling sites on like predicting like stocks?
That's a fantastic question, and I actually have a lot of thoughts on this. Now, I just want to ask one clarifying question. Are you talking about specifically like the implied odds based on what the market is pricing those trades at right now, or like in terms of predictability, what do you mean?
Predictability as going up there.
Trying to predict the general direction.
In the general direction? Yeah, so in essence, my opinion on it is, I'm very like structurally a frequentist in terms of statistics. So anytime I look at these betting sites and I see an implied probability, I don't think about it in terms of, if it's 80-90% implied probability for one candidate or this particular event outcome. I don't think of it in terms of, 9 out of 10 times that will be the occurrence. All I think about it as is in terms of market impact, the market isn't going to react as much as if it was the contrary event, right? So if something's being priced at 90% implied odds, then that means if the other event occurs, the market is going to over exaggerate to that response, right? Because that's not what the expectation was. As a trader, you can structure very interesting trades around that, right? So if you think, hey, like 90%, there's no way, it's like 60%, then it might be worth taking a swing in that capacity, because if you're right, the disproportionate response in the market is something that you can effectively capitalize on. But that's how I think about it. Now, if you look at like the actual regression response and like its ability to like forecast or predict event outcomes, yeah, there's a lot of literature on suggesting that there's no implicit bias, right? Since there's money on the line, people just are going to act with their purest intent to make money. So there's no bias in those statistics, supposedly. So in terms of predicting event outcome, yeah, it can do a pretty darn good job, but in a binary sense, right? Again, think about it more in terms of market impact, I think is the best way to go about it, not 9 out of 10 times something would occur based on these implied odds. That's how I like to think about that space.
Great answer. Any more questions?
I have a question.
Go for it.
I have a question regarding your data acquisition strategy, because I feel like that's one of the most important parts, because that trickles down into everything, right? So if you make a mistake or not as efficient there, it would be like a drastic impact on the result. You had filtered the API to only get the tweets which included like $, the trigger symbol, right? The yeah, like AAPL or AMZ for Amazon. But why did you not like consider also taking in data that just had the name of the companies? All of them, there might be some confusion if someone's talking about like an apple they're eating, or the company or the Amazon rainforest. But still, there would still be a way to like filter that down to like get the accuracy of it referring to the company. Like, is there a reason why you didn't go down that route and just stuck to the tickers?
Yeah, no, that's a really good question, and it turns out to be more of like a signal to noise thing, where I didn't want to create a named entity recognition problem for myself. So what you were talking about there, it's exactly the right intuition, right? Apple that you're eating versus the apple of the stock. And that turns into an NER problem. And it's largely solved now, right? If I ask an LLM, is this body of text talking about the company versus the stock? Yeah, it's going to be able to respond effectively. But at the time, like really, I didn't want to spend too much time on that problem, because then I have to defend my choice in an NER model. is the measurement of the NER effectively introducing more signal than noise? That's another question that I have to ask and answer. So I stuck with the tickers because I know for certain that if I query a document that contains that cache tag in Twitter, that cache tag is literally referring to a financial ticker. So I'm kind of trying to just avoid that step altogether. Whether or not it enhances, and that's a really good question that you're asking, because whether or not that enhances signal value is extremely valid and very likely, right? Intuitively, like you and I could probably agree, yeah, economically it makes sense. I'm going to get a better signal value if I include those tweets. But that turns into another modeling problem. And, you know, effectively, if we can do that, then awesome. We can enhance our signal value. This is the iterative research process. But that's a great question. A great question.
Any more questions? Yeah.
So, if you know, an independent trader wants to create a strategy using relatively low income, how would you recommend getting started?
Yeah, so I will say, in terms of getting involved in the space, my number one best piece of advice that I give, and this is, you know, based on my own experience, is start to build projects. And that could be, if you have no idea where to start, try to replicate results of studies that are available in an open source capacity. You just heard me talk about this research paper for the past hour. Try to build it on a small scale. Try to come up with a way to web scrape tweets, come up with a sentiment model, produce scores, look at the cross-sectional scores, see if there's a correlation between stock returns at that point in time contemporaneously or even in a forward-looking sense. When it comes to actually trading and trading on your own, it starts to get to this kind of like gray area of, you know, I can't really teach you what to do. I can't really do it for you. I really like using poker as an analogy because I can't play the hand for you, right? Because then you're not a poker player. And the only way for you to get involved in the space is to experience it and understand what's going on so you can make those informed decisions yourselves. And that comes from experience, right? I think a big theme throughout this talk was experience, developing experience as a researcher, understanding the space, understanding the quantitative tools that are available to you. And, you know, that's largely what I would say is if you're looking to get started, start getting involved in the space, start building projects.
Yeah, great answer. Yeah, any more questions? Questions? No. Clap. Okay, clap again. Well, it's been a pleasure having you, Roman. I know you have an appointment or another commitment after this, so we'll let you go. But thank you so much for your time. I have shared your community over with our Discord as well, so they will find it there. And also, we shared your YouTube channel. So if you want to talk about anything related to your website or your course, feel free to shout it out.
Yeah, you guys are always welcome. We have the channel and the Discord for you guys. If you guys want to ping me ever, if you want to pick my brain, always happy to answer any questions when it comes to, you know, what you're thinking about in the context of a research project, in the context of your career, if you're looking at getting involved as a researcher, trader, developer, whatever it is. If you ever want to, you know, just hop on and you know, ping me in the chat, I'm very happy to interact and answer any questions that you guys might have. Project suggestions, resumes, CVs, all that as well. You know, feel free to hop on and just give me a shout.
Sounds great. Yeah. Well, thank you so much. Yep. Let's wrap it up. Thank you.
Awesome.
Have a great
Thank
day.
you guys. Thank you so much, guys. Take care. Have a great evening over there.
Yeah. Have a good night.
Have a good
Thanks.
night.
Bye-bye.
All right, and that's going to do it for this seminar at UCSD. It was a wonderful experience. Thank you again to Rudy and the exec team over there at the Triton Quantitative Trading. Very grateful for the opportunity to speak about my research and, you know, share some knowledge in the quant space. I hope you enjoyed this video. It was certainly A very exciting one for me to put together. I hope you learned something. Thank you so much for watching, and I hope to do more of these in the future. Other than that, I'll see you in the next video.